So we're studying the Lamar River watershed, which is just north of the community of Watee. And the reason why we're studying that watershed is because it's being recorded since the 1950s, how much water is coming out of this river over that last, 50, 60, 70 years or so. We're seeing more increases in this river than any other catchment that we have on record. Other catchment that we're comparing this against is the Trout River, which is in the South Decho region, where we're also seeing increases, but not to the same degree. What are the drivers of why we're seeing these different changes from one catchment to the next? They have very similar land cover type, they're similar size, we see a lot of similar permafrost covered. So the question is, what are the main drivers behind the different responses to stream flow that we're seeing across the southern taiga plains in the Northwest Territories?
One of the things that we're forward to in our understanding of our place in the world, I guess you would call it, is you understand how everything's interconnected. The animals are affected by the land, how the land is affected by the water, how the water is affected by people, and there's like this interconnectivity of how everything touches everything. And you take that in consideration of climate change. How does one kind of embrace and look at the issue of climate change, and how do you address something that just seems so big?
Scotty Creek has been running for the last 20 years or so, and over that period of time, we've really come to understand that as permafrost thaws in these wetland-dominated landscapes, it converts this land from a forested area into a lot more bog and muskeg. And what that does is it actually changes how water can move over the land and through the land. And when you get rid of this permafrost, which is relatively impermeable, it allows more water to get to your streams and creeks than before. So as we see permafrost thaw, we see a land cover change and an increase in stream flow. So what we really wanted to test was whether or not we're seeing these same kind of land cover changes in the Lamar River watershed as we are at Scotty Creek, which is very close to the Trout River.
This project is really important for understanding cumulative impacts because monitoring stream flow and the river discharge is the best way of actually seeing the cumulative impact. So when you think about the flow in a river, it actually takes into account all of the hydrologic processes that are happening upstream. So it takes into account changes in precipitation, changes in runoff from the landscape. So if you have changes in permafrost, that's going to be accompanied in that. It takes into account changes in groundwater, what's happening under the Earth's surface. It takes into account changes in lake dynamics. All of these things will impact what water is flowing through the stream, when, and what that kind of shape of the hydrograph or the amount of water flowing through any period of time will look like. And so considering that really helps us to understand how this landscape is changing in response to climate change.
This project sort of started when we were looking at some changing trends in how surface water was changing across the Northwest Territories. We noticed that the site, the Lac Lamard and the Lamart River, were increasing quite rapidly, almost like doubling annual discharge over a 40-year period, almost quadrupling in winter discharge over the same amount of time. This area in the NWT, we have very little data right now. So when we don't have very much data, it's hard to create hypotheses and ideas for why we're seeing this change. So we're out here, thanks to funding from SIMP, to better understand the changes we're seeing on the landscape and try and get a better handle on this story.
We've been working with members from the Clecho government, members of community of Watee on the Lac Lamar side of the project. When we're in the Decho, we've been working with Lidikwe First Nation and environmental monitors who are there and trying to make sure that the research questions that we're answering are really there to serve community needs and interests. So first of all, we went out and talked to community members and tried to understand some of the changes they've seen on the land. We have this long-term data set from the 1950s, but we don't have anything before that. What kind of changes have been observed over this longer time scale that we don't have information for? Next, we went out onto the land and started setting up data collection. We've collected groundwater, surface water, precipitation information, as much as we can about the permafrost conditions and groundwater conditions and water quality that we can use to try to understand the system in these areas. Then the last part of that is to try to take all that information that we learned about the system in the field and represent that in our hydrologic models to try to understand what those different drivers are between these different watersheds and why we're seeing the cumulative effects we are.
So what a hydrologic model does is it takes all of the lakes, rivers, streams, land that water is running off of, it parameterizes them, gives them different numbers, and then you kind of test out different scenarios by changing those inputs to see how that model might respond to changes in climate, to changes in land cover type, maybe a wildfire comes through. And so that's what we use hydrologic models for, is to kind of understand what's going on in terms of water. So when we think about hydrologic models in conjunction with decision making, what we're really interested in is what do we need to pay attention to when we're making our decisions? So because each landscape is different and each system responds differently, it's important to be able to do some sensitivity analysis. So what is going on in this landscape that's going to be driving these changes? Because then we can then understand, well, what's going to be coming next? And that will help us design policies that will be resilient to those changes.
Directing research at the Scotty Creek Research Station to focus on what the needs of the communities are in regards to research. But if we can focus it and complement the work that scientists from across the world depend on Scotty Creek to provide, but also kind of focus it in the direction that benefits the communities and our understanding so we can appreciably participate and work on the land, is such a good thing.
So when we have more groundwater contributions to streams, it changes the water chemistry. We see more nutrients, more minerals. That has impacts for water quality and baseline conditions, which is something that First Nations have been really concerned about and interested in building a data set of. The other thing is in the Lamar River watershed, the Lamar River is a really important overwintering site for coney fish population. And so working with both wildlife biologists, they've been really interested in how this stream might change in the future in terms of managing and protecting critical fish species. So the main difference at the Lamar River from those in the southern Decho is that it has that same land cover, but it also is underlain by a much more permeable ground. There's a lot of fractured rock. You can get a lot more water flowing through it than the silty clay in the Decho. And so we think the main difference here is we do have that land cover change that's driving increases in stream flow, but we're also seeing more groundwater flowing through the ground as permafrost is thawing and going into our streams. And then the other thing we found is we're pretty sure that precipitation has been increasing in this region, which when you combine increases in precipitation, land cover change, and greater groundwater contributions, those all combine to really increase stream flow much more than we're seeing in other places.